Hey guys, Ms. Gosling here. In this video, you're going to learn about complex circuits. By the end of the video, you'll be able to solve problems involving complex circuits. So let's go ahead and get started. And of course, what kind of a physics video would this be if we didn't start with a little definition? And that is, what is a complex circuit? A complex circuit, very simply, is a circuit with both series and parallel components. So not all circuits are completely a series circuit. So not all circuits look like either 1 or 2. Circuits are not that perfect binary usually. Instead, most of the circuits that we see have some pieces that look like a series circuit and some pieces that look like a parallel circuit. Just because the circuit is complex, however, doesn't mean that we can't still find our equivalent resistance. So the easiest way to figure out these circuits is to start by figuring out what resistor doesn't belong. So looking at the circuit below, pause the video and think, which of the 3 resistors doesn't belong? Okay, so hopefully you've taken the time to pause and make your decision. When I look at this, the resistor that doesn't belong is the 2 ohm resistor, because the 5 ohm resistor and 6 ohm resistor are next to each other on the same piece of wire, while the 2 ohm resistor is up by itself. So when I'm solving this circuit, what I'm going to do is I'm going to begin by pretending that my 2 ohm resistor doesn't exist. So if I want to find the equivalent resistance for my other resistors, my 5 and my 6, I can see that these 2 are in a series with one another because they're on the same chunk of wire. So that means that their equivalent resistance is 6 plus 5, or 11 ohms. What that means, remember, is that I could write, if I were to draw a circuit with only 2 resistors, what I could do is I could replace my 5 and my 6 ohm resistors with one 11 ohm resistor. However, I still haven't looked at my 2 ohm resistor, so that 2 ohm resistor is going to be exactly where it is in my original circuit diagram. So what I've done is I've used my series rule to combine my 2 resistors in one wire together. From here, I now have a much simpler parallel circuit equation, or parallel circuit setup. So I can find my equivalent resistance by using my parallel equivalent resistance equation. 1 over Req equals 1 over 2 plus 1 over 11. And I'm going to show you a slightly different method for solving this question than I did in the parallel circuits video. So what I'm going to do is, instead of finding a common denominator and adding my fractions like fractions, instead I'm going to go ahead and turn them into decimals. So instead of 1/2, I can write 0.5. And instead of 1/11, I can write 0.091. And so what I'm going to do is I'm going to go ahead and add those together. And when I do, I get that 1 over Req is equal to 0.591. That means my equivalent resistance is equal to 1 over 0.591. Because remember, my last step is flipping my fractions. And if I have a decimal, my number is not over anything, that's the same as having a number divided by 1. Or sorry, having a number dividing 1. When I put that in my calculator, I get that my equivalent resistance for my entire circuit is 1.69. So there you have it. I have found my equivalent resistance for this complex circuit. Moving on, now that I've found my equivalent resistance, and that's 1.69 ohms, I can go ahead and figure out what my current is. So I know that V is equal to I times Req, just like it has been for all of the problems that we've done so far in this unit. What that means is that my current is equal to V divided by Req. But again, I'm going to do this slightly differently than I have in some of our other videos. I'm going to start by plugging my numbers in. So I know that my voltage is 5, because that is what my battery is labeled with. I is my unknown, so I'm going to leave that as a letter. And my equivalent resistance, Req, I just solved as being 1.69 ohms. So now my job is to get I by itself. And to do that, I'm going to divide both sides by 1.69. And what I'll get is that my current is equal to 2.96 amps. And if I was properly rounding that and paying attention to sig figs, my current would be 3 amps. And there you have it, guys. Here's how I can solve a complex circuit problem to find both my equivalent resistance and my current. This is one of the 2 kinds of complex circuit questions you might get asked. And again, in this question, what I did was first, I dealt with my series components. So that was my 6 ohm resistor and my 5 ohm resistor. Then I found REQ. So my next step is to find REQ using my parallel circuits rule. Finally, I used V equals I times REQ to find I. I might instead ask you to find V. That's going to depend on the question, but at that step, we are at the easier part of our problem. So this is my first kind of question. Let's look at the second kind of circuit I might ask you about. So like before, what I'm going to do is ask you to take a look at the circuit, pause the video, and decide which of my 3 resistors doesn't belong. The 2 ohm resistor, the 5 ohm resistor, or the 6 ohm resistor. Pause the video, think about it, and restart when you feel like you have an answer. Okay, so hopefully your answer is the same as mine. When I looked at this video, it looked like the 6 ohm resistor didn't belong because the 6 ohm resistor is off on the side by itself, kind of in the same section as the battery, while my 2 ohm and 5 ohm resistors are both after my circuit has split into 2 different wires. So my 2 and my 5 ohm resistor are where I'm going to start. And my 2 ohm and 5 ohm resistors are in parallel, so I'm going to go ahead and use my parallel circuit equation to figure out their equivalent resistance. And what I'm going to get is that 1 over REQ is equal to 1 over 2 plus 1 over 5. That is equal to 7 over 10 if you do the math, or 0.7 if you do the math by finding decimals instead of using fractions. Regardless, that means that REQ is equal to 10 over 7, or in decimal form, 1.4 ohms. And again, if I was rounding properly to 1 sig fig, I would say 1 ohm. But as I'm kind of in the middle of a question, the more significant figures that I list, the more likely that my final answer will be correct to the right level of precision. I always recommend have one more decimal place in your rounding when you're in the middle of a question than I had in the numbers that I gave. Do your final rounding at the very end. Regardless, when I'm looking at this circuit, what I have done is I have combined my 2 ohm resistor and my 5 ohm resistor into one. So my 6 ohm resistor is just the way it always has been. Nothing has changed. But instead of my 2 ohm and my 5 ohm resistor, I can replace them with that equivalent resistance that I just found of 1.4 ohms. So now my circuit is a lot simpler because it's just a series circuit. So I should be able to very easily figure out what my equivalent resistance is because my 6 ohm and 1.4 ohm resistor are now in a series. So my equivalent resistance is 6 ohms plus 1.4 ohms, or 7.4 ohms. And there you have it, guys. I have now found my equivalent resistor for this circuit. Again, from here, I could find current. I'm going to go ahead and skip that step because I know you have done that many, many times before. But now that I found REQ, it's very easy for me to use Ohm's law to figure out my missing voltage or missing current, depending on the question I'm given. So with that, let's go ahead and talk takeaways. First of all, a complex circuit has both series and parallel components. To figure out where to start when solving a complex circuit, I want to find the resistor that stands out. So find me the odd one out. Find me the resistor marching to the beat of a different drummer. And then finally, once I have found REQ, I can replace the resistors I just combined with one resistor. This is helpful because it turns my complex circuit into a simple series or parallel circuit. And from there, it's a lot easier to finish solving the question. So with that, go ahead and get started on the practice. See if you can figure out for the practice problems here, which of the problems are like the first circuit that I told you, that I showed you and which of the problems are like the second circuit that I showed you. That is going to be key for understanding this unit as you go forward. So with that, go ahead and solve some questions on your own. Best of luck and happy solving.